In 1995, philosopher David Chalmers formalized what he called the hard problem of consciousness. Even if we map every synapse and functional pathway in the brain, we still face an inexplicable explanatory gap. We have no mechanism to explain how objective physical biology transforms into subjective first-person experience, the feeling of the warmth of the sun or hearing a melody. Traditional physicalism hits this wall because of its starting parameters. It begins with the assumption of inert matter and then attempts to derive subjective experience from complex arrangements of those physical parts. Long before modern neuroscience, the ancient Indian philosophical tradition of Advaita Vedanta addressed this gap by inverting the physicalist premise entirely. This visualization illustrates the core premise of Advaita. Instead of starting with matter, it posits that pure, non-dual consciousness, termed Brahman, is the fundamental substrate of reality. The question is not how matter generates consciousness, but how matter appears within awareness in the first place. Under this framework, physical reality isn't separate from the observer. The distinct boundaries we perceive are viewed as localized patterns occurring within a single, continuous field. This philosophical inversion forces neuroscience to look past mere neural correlates, the specific circuits that light up during a task, and instead identify the underlying principles that govern how physical systems exert causal power over themselves. Today, the search for those principles is dominated by three mathematical formalisms: global neuronal workspace theory, integrated information theory, and the free energy principle. But theoretical math remains speculative without empirical validation, raising the question of how to verify these models in human subjects. To bridge this gap, researchers have adopted a methodology proposed by Francisco Varela, known as neurophenomenology. As seen in this clinical environment, the method involves a bidirectional flow. It pairs highly trained first-person reports of experience with third-person neuroimaging data, ensuring that neither the subjective report nor the brain activity is ignored. By using advanced contemplatives as subjects, researchers have a replicable way to observe consciousness in its most stable and refined forms, providing a more precise map for neuroscience to follow. The epicenter for testing these theories is the Cogitate Consortium, which includes researchers from the University of Oxford. This global group was formed to put the proponents of conflicting theories through a rigorous empirical test. The first model, global neuronal workspace theory, or GNWT, argues that consciousness is synonymous with access. If you can hold information, speak about it, and use it to perform a task, you are conscious of it. Biologically, GNWT relies on a binary ignition of the prefrontal cortex. Once this threshold is hit, the information is broadcast globally across the brain so other systems can use it. Integrated information theory, or IIT, takes a different starting point. It begins with the phenomenological certainty that our experience exists and derives physical postulates that a hardware system must satisfy to account for it. We can see the mechanistic differences here. While GNWT focuses on broadcasting, IIT focuses on the system's causal power upon itself. This is measured mathematically by phi, which quantifies the degree to which a system's information is generated by the whole over and above its parts. Because of this requirement for re-entrant architecture, IIT predicts the physical basis of consciousness is located in the posterior cortical hot zone, comprising the parietal, occipital, and temporal regions. By defining consciousness as an intrinsic property of a system's causal structure, IIT provides a mathematical mirror to the Advaita Vedanta concept of an underlying conscious substrate. These theories don't just differ in their math, they predict that consciousness exists in entirely different anatomical locations, using entirely different physical mechanisms. A third framework, developed by Karl Friston, is the free energy principle. It suggests the brain is not a passive receiver of signals, but an active prediction machine. This illustrates active inference. Higher levels of the brain generate top-down predictions about what lower levels are sensing. These are compared with incoming data to calculate a prediction error, which the brain then works to minimize by refining its internal model. To maintain its organization against entropy, the system must separate its internal states from the environment. This statistical boundary is known as a Markov blanket. Because the Markov blanket limits our contact with the outside world to mere sensory signals, our reality is effectively a constructed internal model. This provides a mechanistic parallel to the Buddhist concept of emptiness, where the perceived world is seen as a mental fabrication used to resolve the friction of incoming data. We can also map active inference to the dynamism of Kashmir Shaivism, which introduces the concept of spanda. Spanda frames the ultimate reality as a creative vibration or pulsation. This matches the dynamic, embodied coupling of an organism that doesn't just sit and wait for data, but actively tests its environment to confirm its internal predictions. The insights of ancient Eastern mysticism and the math of modern thermodynamics are both describing a system defined by its ongoing engagement with its own internal and external boundaries. To find which of these theories is correct, researchers must strip consciousness down to its simplest possible form. This is the minimal model approach, which uses advanced meditative phenomena to isolate the core features of awareness. Researchers focus first on advanced concentrative absorption meditation, or the jhanas. In this state, typical features like perception, thought, and emotion are attenuated. What remains is a highly abstract, simplified form of awareness that still feels like something to the subject. Then there is the limit of this attenuation, nirodha, or cessation events. In a cessation event, consciousness itself is reported to be temporarily suspended. There is a complete gap in experience, followed by a system reset. By using these reproducible states as experimental anchors, science can perform precise contrasts between presence and absence, allowing researchers to evaluate which mathematical theories actually hold up under extreme conditions. This evaluation is happening now through the Cogitate Consortium's adversarial collaboration. This brilliant protocol forced rival theorists to agree on mutually exclusive predictions before data collection. GNWT predicts that without cognitive contents, prefrontal ignition should cease, implying unconsciousness. Conversely, IIT predicts that during subjective experience, the posterior hot zone maintains high phi, keeping consciousness active. When researchers recorded the neural activity of expert practitioners in these states, the findings highlighted a significant challenge for existing theories. The data showed a dramatic drop in prefrontal engagement and a quietening of the default mode network. The areas associated with active cognitive doing were largely silent. This creates a problem for GNWT's active broadcasting. The prefrontal workspace isn't ignited, yet subjects experience a stable state of awareness. This result aligns more closely with IIT's model. It suggests that consciousness is not tied to active cognitive tasks or broadcasting, but to the intrinsic causal structure of the posterior cortex. The evidence suggests that consciousness is not something the brain does through active reporting, but an inherent state of being that persists even when the prefrontal cortex is offline. While absorption meditation validates the structure of awareness, cessation events provide the final test for the free energy principle. If consciousness is defined as the active process of prediction error minimization, what happens when that process stops entirely? During cessation, the brain's predictive hierarchy temporarily flattens. The precision weighting that maintains the Markov blanket, the boundary between self and world, drops to zero. The system no longer predicts a self or an environment, and the conscious field suspends entirely. By mapping these states to mathematical formalisms, we are developing a blueprint for how the brain's architecture constructs our sense of existence. We are beginning to see how the physical patterns of the brain create the very perspective from which we view the world.